Okay, so homework number 2 is going to be on the stuff that we've covered up to today. So everything that you're asked to do in homework number 2 will be things that we'll cover in class. By the end of class today, you'll be comfortable with everything you need to know for homework number 2. For homework number 2, I'm asking you to turn in a diary text file. That's the thing that you're going to be asked to turn in. So how do we create diary files and what do we do with them? First off, I ask you to submit one diary file that has all of the answers and kind of all of the work that you're going to show for all the problems for homework number 2. So how do we do that, and then what happens if you need to have more than one file, and how do you edit these files? So let's go back to MATLAB. So in MATLAB, if we want to start a diary file, we just use the command diary. So D-I-A-R-Y, open parentheses, and then inside the single quotes, inside the parentheses, we have to tell MATLAB what we want to call our diary file. We can call it pretty much anything that we want, except for I've asked you for the homework to follow a specific format so that when we're grading, all the files are easy for us to figure out whose is whose. Because when we download stuff, all the submissions that get submitted to Isidore, when we download them, they're all in one big folder. So if you don't have your name on it, then we have to go and figure out whose file is whose, and it's one extra step that we'd like to avoid. So if you can put your first and last name in your diary file, so let's see. So Allison Kinney is my first and last name, so don't put Allison Kinney as your first and last name. And then I've asked you to do, I think, homework hw2.txt. If you forget the .txt, that's fine. It's still going to make it a text file. It's just not going to have that extension on there, but it's still going to record it in the right way. So once we press enter here, now it's going to start doing MATLAB's going to start recording and writing to that file everything that we put into our command window. Even if we hit the CLC and we erase the things in the command window, all that stuff is still in our diary file. So it's just a continuous log of what we've done. Question?
Even with pressing clear?
Even when you press clear, the stuff that has been to the diary file after you wrote the diary command is going to continue going to the diary file. So it's just a continuous, long, big file until you either close MATLAB or you use the diary space off command, and then that stops writing to the file. So there's those two different options. If we were to try to go open the file while we're writing to it, it usually looks blank. So some people kind of freak out that they can't see what's in the diary file while they're writing to it. Oh, MATLAB's not working. You have to wait until you close it before it actually, most of the time, shows up in there. So the way I've asked you to do your homework is for every problem that you have in the homework, so say problem 1, to insert what's called a comment in MATLAB. So a comment for any programming languages are things, kind of notes to yourself, comments about what's going on. It's not code that gets run by MATLAB. It's just kind of ignored by MATLAB or whatever programming language. So the way you do comments in MATLAB is that you put a %, and you'll see that MATLAB has changed the font to be green. And then anything you write on that line after the % is a comment, and MATLAB doesn't care what is there. It pretty much ignores all of that stuff. So I've asked you to put comments in your code to tell us what problem it is. So problem 2.1, and then the answer, the work for problem 2.1 right after that. That way it's organized, and we can find, when we're going to grade, where things are in the diary file. So like I said, the diary file is going to have this big, long kind of log of everything that you've done. When you're done with your diary file, you use the command diary off. And if we double-click and open this file, text file in MATLAB, you'll see what's inside of it. So you'll now see all of the things that I put in there. So we just had those 2 comments and then the diary off command. So what happens? So you work on problem number 1, problem number 2, then you have to go to class or whatever. You can close your diary file, and what I would recommend is that you make a new diary file the next time you get into MATLAB. So part 1, part 2, part whatever, and then you can merge those all together to turn one file in for your homework. So this is the one I just created. I created a diary file earlier in my office with some more code into it. All I have to do is just copy the text from the one file into the other file, and you can merge those all together and then resave this text file. So that's what I'm asking you to do. Please, put it all in one file. It's just easier for us to grade that way. And then also, if you have any errors, so in your diary file, if you tried something out, you got an error from MATLAB, that's not the solution that you actually want to turn in, you can go through and delete that stuff out of your diary file so that we don't have to look at 5 mistakes before you finally found the right answer and we know what to grade. So please make sure that what's in your diary file are the things that you actually want us to grade. So questions about that, Don?
What did you type in to put like problem 2.1 or 1.1?
So that's just the comment. So that's this green. So down here with the percent sign.
Is that a percent sign?
Mm-hmm.
Okay.
So this is like a comma if you put the percent.
The percent sign, yeah, it's just a comment. That's stuff that MATLAB ignores. It's just there for informational purposes. Any other questions about diary files or editing them or anything like that? So once you've edited it, you can just hit save and MATLAB will update that file has got that information in it.
Can you just like open it back up and keep typing then?
They say that you can do that. So they say that you can execute just that same diary command and it should keep writing to it. I've had situations where it's deleted the stuff that was in there before. So I would caution you against doing that because then you're going to lose the things. They claim that will normally work, and most of the time it does, but always to be on the safe side, I always just create another one and then merge them all together, and then I know it's going to be there and I'm not losing anything. So it's up to you. If you want to roll the die and be risky, maybe you could try it. But all right, any other questions about creating diary files? Okay. So you can just open up the two files, copy and paste information back and forth, and then save it again. Yeah. Okay. So that's the quick stuff about diary files. So what I'm going to do now is we're going to pass out two different things. So I'm going to pass out the in-class exercise. There's two sides to this. The first 8 problems or 8 questions, or no, 7 questions, sorry, are things that you would put into a diary file similar to what I just showed you, and then whatever you have done at the end of class today, upload, and that'll be your in-class exercise that I'll look at, give you feedback on by the end of class. If you don't get it all done, it's not that big of a deal. Just get done what you can. Question number 8 on the in-class exercise has some what I like to call debugging questions, so related to errors in MATLAB. I've given you some code and I've given you the error that MATLAB produces because that code is incorrect, and you've been asked to rewrite the code, so correct it and tell me why you needed to make that correction. So what happened, why was MATLAB angry and gave you an error? So what we're going to do is I'm going to have you guys fill this out on here, and you can what we're going to do at the beginning of next class is we'll just review the answers. So if you bring this filled out tomorrow, Friday is our next class, and we'll review the answers for the handwritten part. I often ask these types of questions on exams and quizzes, so make sure you kind of understand how to do these. All right, so I'm going to pass these out. I'm also going to give every pair of people an index card. So this is related to the built-in MATLAB functions. So MATLAB has a lot of built-in functions. They do a lot of interesting mathematical operations really quickly. Rather than going through 20 of them, I'm going to pass out cards, and it's your responsibility, you and your partner's responsibility, to research what this card, what the function is in MATLAB that does this, that's on your card, and you have to figure out what the function does and come up with an example of how to use the function, given a vector or a matrix, whatever you want. And then at, I don't know, maybe 3 o'clock, we'll break for a little bit and have everybody talk about their built-in functions. So one person's going to explain it to the class, and then the second person posts it to Isidore. We have a forum where I started a built-in MATLAB function. That way you guys kind of have a list of all these functions that you want if you want to refer to them. So do work on the built-in function first. If you get done, you can start on your in-class exercise. So I'm going to have both of those going at the same time. All right? So what I'm going to do is, like I said, every group is going to tell us how to use the function. So I'm going to clear out my workspace, and I'm going to clear off my command window, and then we're going to kind of work on the example of how to use the function together so everybody can kind of see how they work. In order to do that, I'm going to create a couple vectors and a matrix, and we'll just kind of use those as our basic vectors and matrices. So I'm going to create an x vector, I don't know, 1, 2, incrementing by 5 up to 20. So what happened there? How come I didn't get 20 at the end of my x vector? It would end on 21, right? The next one would be 21. So when you use the colon operator, if you don't quite get the finish value in the right range, MATLAB's kind of like The Price is Right, where it gets as close to the number without going over. So it's not going to, I told it couldn't go above 20, so it didn't print out 21. So that's another thing that you'll see with the colon operator. So we've got x, and let's create, I don't know, P is our matrix. So we'll do 2 to 6 on the first row, linspace 1 to 6, 3 values. We'll do a 2-row by 3-column matrix, and now we'll start talking about our functions. So let's see. So I get everybody. I'm going to start here in the front row. So Rose and Blake, what do you guys have? You can stand up if you want to. You don't have to.
Our function is the sort function.
Okay.
So if you wanted to sort vector x, it would look like x equals sort parentheses x close parentheses. And that will just organize your numbers in ascending order. So if instead of it was like 6, 1, 16, 11, it would put it in the 1, 6, 11, 16 order.
Right. So that one was a little bit boring. So if I had b is equal to 10, -2, 0, for example, those are in descending order. If I sort my b vector, it's going to flip them all around and sort them from smallest to largest. So sorting by default goes from smallest to largest. All right, anything else for you guys?
For matrices, if you wanted to, if you just do the regular sort, the matrix that you were doing, it would naturally do ascending order by columns by default. But if you wanted to switch it, like organize them ascending by rows, you would have to put in a comma 2 after your vector name.
Right. So our original p vector, you'll see in the first column had 2 and then 1. When I sorted the p vector up here, or the p matrix up at the top, it sorted that column, so it flipped the 1 and the 2. So now they're in, ascending order. And then all of our rows are in ascending order already, so that one didn't do anything. All right, thank you. So, one more. Extra mile. All right.
If you wanted to, since it naturally does it by ascending order, if you wanted to change it to descending, you would put a comma and then a single apostrophe, descend, single apostrophe, close it.
Right. So if I want to do it in descending order, which it already was, then I can tell MATLAB to do that as well. So I could have done that with our x vector, and it would flip around the order. All right, thank you. So now Lauren and Kayla, what do you all have?
We had the task of finding a MATLAB function to calculate the remainder of a quotient. And what you need to do for that is you got your numbers, like your numerator and your denominator. You're going to type mod in your command window, followed by an open parenthesis. And then you put your numerator there, followed by a comma, and then the denominator. And you close it with like the parentheses.
Mm-hmm.
And you hit enter. And it'll spit out ANS of remainder, whatever you wanted.
Right, so the remainder is just kind of, if you remember back to when you learned long division, the thing that's left over. So we have 6 in this case, and then divided by 4. So you put 4 into 6 one time, you have leftover 2. So that's what MATLAB gives you. There's also a function called rem, R-E-M, very similar. There's some slight differences between the modulus mod function and the remainder rem function, but for the most part they act the same. So you got those 2 options. All right, thank you. So John and TJ, what do you all have?
We have a function diff that
Okay.
calculates a difference within a vector
Okay.
between the different, I don't know.
Elements of the vector?
Yeah.
Yeah.
that'll do it.
So if I take diff of our x vector, what am I going to get? So it's just the difference between the values. So we look at our x vector, and that was incrementing by 5, so all my diff values, my differences are 5. So if you have a vector that was created by the colon operator, then you know what to expect when you get your diff back. If not, if you created some random vector that isn't increasing by the same amount, you're going to get different values back from diff. Okay? Anything else for you guys? Okay. Sawyer, what did you have?
Alright, I have cosine and radians.
Okay.
So you just type in COS, parentheses, and whatever number you got that you put in X.
Okay.
And that'll just give you the cosine and radians.
Yep. So that's an important thing to remember. So important note, all trigonometric functions in MATLAB, so cosine, sine, tangent, all of those, by default operate in radians. So we will get to somebody who has the thing that tells us how to do that in degrees, but just by default, remember, if you type in cosine, it's expecting whatever to be inside of that cosine to be in radians. So that's important to remember. All right, Joe and Greg, what did y'all have?
We had the floor function, which
Okay.
rounds down to the nearest integer. So if you had a vector or a matrix, and you just type floor and then parentheses whatever variable used, and then hit enter, it'll round down any decimals down to the nearest integer.
Okay, so if I had, for example, 0.9, floor is going to round that down all the way to 0. So floor goes down to the nearest integer. Yep.
Is that like a useful function? Is that a useful function?
It probably isn't the most useful function, but if there are a couple different applications, I guess, where you might want that, sometimes you just need integer values, and so you don't care if it's anywhere between 0 and 1 or 10 and 11 or whatever it is, and then you can use the floor. There's also a corresponding function that rounds things up to the nearest integer. They're nice tricks that MATLAB has, but kind of like you said, not the most useful. You probably wouldn't use it all that often. So I will tell you, though, that your final course grade, I take and I round up to the nearest integer. So I use the ceiling function for that. So whoever's got the ceiling function, we got a preview of that. So that's the way I use it. All right, Dan and Abdul, what did you guys have?
We had standard deviation,
Okay.
which is a statistical measure of the variance between the numbers within a set.
Right.
And the command for it is std.
Yep. So if I take the standard deviation of our x vector, it gives me back one number, and like you're saying, it's the variance in that. So it took our x vector. What a standard deviation does, it takes the x vector, calculates the average of those 4 numbers, and then it calculates kind of how much all the numbers are spread away from the average. That's what a standard deviation is. So MATLAB can calculate that easily. All right, thank you. So Chloe and Alex, what did y'all have?
We had calculate a maximum,
Okay.
and so you just put max and then parentheses whatever your matrix was.
Okay.
And if it's a vector, then it will just give you one number.
Mm-hmm.
And then if it's a matrix, it'll give you a row
Right, so the max function gives you, if you have a matrix, it's the maximum of each column. You can also kind of like sort, you can flip it into the other mode and you can get the maximum of each row if you want to. All right, thank you. So, Kevin and Tom, what did y'all have?
Round to the nearest integer.
Okay.
So you just say, for example, like y equals round, type out round, and then parentheses x, and then it'll round around everything of the matrix to that integer.
Right, so if I
Nearest
take,
integer.
yeah, so if I have just round of 0.3, it's going to round it down to 0. If I round anything above 0.5, so say 0.6, it's going to round that up to 1. So round is your typical rounding function. Floor that we talked about is a little bit different, and then we'll get to the rounding up one soon, probably. All right, so Chase and Abdul-Amin, is that right? What did you guys have?
Absolute value.
Okay.
Just absolute x, which is
ABS, right? So say -10, so that just gives me the positive value, right? So absolute value, not too hard, but a handy one to have around. All right, so Ryan and Mohammed. Square root? Uh-huh. So we could take the square root of all the values in our matrix or all the values in a vector, and that's just the square root math function. All right, thank you. So Coley and Gunnar, what did you guys have? Or no, Coley was with Catherine, right?
Okay, we had rounding up to the nearest integer, so this one's like the floor one, except you type in CEIL,
Mm-hmm.
and then you can put in like your number, or you can do your vector matrix.
Right, so ceiling is the opposite of floor, so ceiling rounds up to the nearest integer. So you could think about ceiling, pushing it up to the ceiling, floor, pushing down to the floor. That's how I always remember them. So like I said, when I calculate your final grade in this class, if you have a 89.00001, that gets rounded up all the way to a 90. So it's my nice gift to you guys. All right, so who's next? Gunnar and David, what y'all have?
We calculate tangent degrees.
Okay.
You just have to type in, run like the radian, you have to type in TA and T and whatever you want.
Right, so in order to flip the trig functions into degree mode, you type the name of the trig function, tan or cosine, COS, and then you put a D at the end of it. And then MATLAB's expecting input in degrees instead of radians. So make sure when you're calculating trig functions in this class, you know which version you should be using. If I give you numbers in degrees, you use the trig functions with the D's. If I give you numbers in radians, you use the regular trig functions. All right, Leah and Adam, what y'all have?
We had calculated sum,
Okay.
which is pretty simple.
Sum, right?
Yeah, you put a plus sign normally, or you can write sum, and then you can put either like two numbers. I think you can do like B and then A.
So we could do our whole vector. So if I did sum of B, it's going to add up all the numbers in the vector. What happens if I do sum of our matrix P? I get the sum of what? Sum of each column. So it's going to sum up each column. 2 plus 1 is 3. 4 plus 3.5 is 7.5. So it just adds up everything in each column. All right. Let's see. Ron and Haosung, what did you guys have?
We just calculate the minimum value.
The minimum? Okay. So what's the minimum function?
Like in a matrix or vector, you can just put in the MIN.
MIN? Uh-huh.
So the minimum value would.
So minimum of vector B is 0, so it'll give us one number. Same thing if I take the minimum of P, our matrix, it's going to give me the minimum in each column. So a lot of these functions work basically the same way. So who's next? Yichung and Dave? Or Dan, sorry.
Okay, we have the job of calculating the length of the longest dimension of a matrix.
Okay.
Basically, you can make up any matrix you want, whatever you set that to. You put, so if you made it A,
Mm-hmm.
and then you type in
Okay, so we've got P floating around. So P is our matrix. It has 2 rows and 3 columns. So length is going to give us the longest dimension, so it's going to tell us 3. If we took the length of our P vector that we have there, or no, not P, B, it has 6 numbers in it, so it's going to give us 6 as the longest dimension. So length is always the longest dimension, either the number of rows or the number of columns that's the biggest. All right, Tark and Andrew, what did you guys have?
Yep, we were told to calculate the number of elements in a matrix.
Okay.
So the function that we found was numL,
Uh-huh.
N-U-M-E-L. So the way to use it is set of variables, say n equals numL, and then you do in parentheses any matrix that you want, and it will give you all the number of elements within that matrix.
Right, so the number of elements function is numL. If I take the number of elements of B, which is a row vector, it's going to give me the same thing that length did. It says 6. If I take the number of elements of my P matrix that I have, what is it going to give me? Any guesses? How many elements do we have in P? We also have 6 because we had 2 rows, 3 columns. So that's what number of elements does. All right, we just have one more, I think. Or no, a couple more, right? So Hunter and Ethan, what did you guys have?
We had generate random numbers.
Okay.
So the function is RAND.
Yep.
And parentheses, and you'll just put the number of rows, comma, columns, and then you just get a random array of numbers.
Right, so RAND gives us numbers between 0 and 1. How many rows, how many columns, you tell it, and then that's what MATLAB gives you. All right, we're going to finish up these last 2, and then I'll let you guys go. I know we're out of time. All right.
Okay, solvable is the algorithm.
Okay.
So let's take the algorithm,
So mean is the name of the function, so mean of B is going to give me the average. All right, one more. Size, okay. And that tells me, so size tells me the number of rows and the number of columns in a matrix or a vector. All right, so that's all we have for today. If you, like I said, you guys can turn in what you have for your in-class exercise. We will probably submit, we didn't have a whole lot of time to work on it today. We will probably do a little bit more at the beginning of class next time. So turn in what you have today.